Hi, everybody, and welcome to Lab 4 in Physics 1105. Okay, so this will be your first lab where you will need the lab kit, although to be honest, you don't really need it 100%. But what you will need is a marble. You might have one lying around the house. You can use other balls, maybe like a golf ball would be fine. It has to be a heavier ball, but if you look in your lab kit, let's see if I can get this to work. You'll see a little baggie that has a spring and a marble. So you just need the marble part of this for this lab. Okay. So what you're going to be doing is you're going to be investigating some projectile motion and specifically predicting the range of a projectile. Okay, so how do we make a projectile work for us in this lab? So let's take a look at the manual. Okay, so of course there's an introduction here, which you should read. And the pre-lab is on Moodle. But here you can see there's two parts. One is you're going to set up a ramp. Now this can be, like a notebook or something that you've put on a table, figure out some way to make a little ramp. And you want to have a little bit of room here of flat space before this projectile goes off the table. Okay, so let's think about this for a minute. So when this comes down, when you roll your marble, and you're going to want to roll the marble several times down the ramp, right? You're going to be taking several takes of this data in the beginning here, because the first part of this is just to determine the speed with which this projectile, the marble, is leaving this table. So this is the speed in the X direction. Horizontal we'll call X, right? The speed in the Y direction initially is 0. Notice there's no, you're not throwing it down. You didn't throw it up first, right? It has 0 speed in the Y direction initially. Okay. But you want to leave a little room here, and you're going to try to roll it every time you take data from the same point up here. Maybe a good idea to mark that space, that place that you're letting it go from. Okay, and you're not going to push it. You're just going to let it roll. All right. Now, so the first thing we're doing here is we're measuring the initial speed. Okay, so this will help to when we do the next part of the experiment. Okay, so you're going to take data several times so you can get a 90% confidence interval, and you're going to use your kinematic equations that you learned for projectile motion to predict this speed or calculate the speed given the height of the table from the floor and how far out this projectile goes before it hits the floor. Now, if you have carbon paper, which I didn't mention here because some of you may not have carbon paper in your kits. If you have carbon paper, that's nice. You can lay a piece of paper down, put the carbon paper over it. You're going to have to do this experiment a little bit to see where the marble is hitting in general. But the carbon paper is nice because it'll make a little dot on the paper. But otherwise, you can just watch where it hits, right? And make the dot yourself. It'll probably dent the paper a little bit. Okay, so you're going to see how far from the launch point, which is here in this direction, the horizontal distance, does it hit, right? And if you do that several times, you're going to take data. You should be able to predict with using your kinematic equations what the initial velocity is. All right, once you do that, you're going to change it up a little. You're going to make the ramp a little higher. Okay, so and then you're going to try to predict, right, what the range is going to be. You want to set this up exactly the same. You want the same amount of distance here, right? Except for now you've just raised the whole thing, right? So you've raised the entire ramp. Again, you're going to let your ball go from the same place, right? And this time, what the initial velocity is because you've already measured it, right? You've measured the initial velocity. That is not going to change, this initial x velocity. What will change is the range, right? How far does it go before it hits, right? Because it's higher up now. All right, so you're trying to predict, right, the range so that you compare and then measure it so you can compare with the predicted value given by the equation. Now this looks like a big nasty equation. It's really not though. Remember that this theta is the launch angle, and notice we have a 0 launch angle. We're not, We're not launching it like this or launching it like this. We're launching it like this, a 0 launch angle. So if that's the case, cosine theta is 1, sine theta is 0. So imagine just cross out everything with a sine theta in it, and this becomes a much simpler equation. Be careful here. Delta y is the final position in y minus the initial position. It's going to be negative, so you can just ignore this negative sign, and this delta y is just the height of the table. So it's a very simple equation. It's going to be very similar to the one you used already to measure V naught or to predict V naught, calculate V naught. Okay. All right. Again, this one here is a informal. There will be a quiz right here about what you did. And of course, there's a pre-lab. All right. Well, I hope that this is fun for you to do a little experiment finally with, well, in lab 1, you did throw some coins, but this is a little bit more of a kinematics experiment. All right. Well, good luck, and we'll looking forward to seeing what you guys do with this lab.